Today we're doing 7.6, which is factoring polynomials using the GCF. GCF, remember, is the greatest common factor. And our learning goal for today will be I will factor polynomials using the greatest common factor and I will solve polynomial equations by factoring. So in your previous lesson, you used the zero product property where you started with something that was already in factored form and then you were able to solve it using that zero product property. Today we're going to be starting with standard form. So something that looks like this. That's standard form, and we're going to put it into factored form. So there are actually a couple of different ways to factor something. We're starting off with greatest common factor. This is just the most straightforward one. You should always try this or see if this is possible first, and then proceed with the things that we're going to be learning over the next couple of lessons. So for this guy, what I want to do is I want to see what the greatest common factor is between these two terms. So if I look at the 4 and the 12, the greatest common factor of 4 and 12 is 4. Now, I can tell just by looking that that's what this greatest common factor is. Remember, that's the biggest factor, or the greatest number. That's a factor of 4 and 12. I could always list the factors of both numbers. I could make my factor tree and multiply all the things they have in common. There are lots of ways to find the greatest common factor. But since that's not really the point of this lesson, these are all pretty obvious, I think. So hopefully it won't be too much work to figure out what the greatest common factors are. So I looked at the numbers, or the coefficients, in this case that's a constant, and I found the greatest common factor for those. Then I need to look at the variables. We have an x squared. This guy doesn't have a variable, so they don't have a variable in common, which means my greatest common factor of these two terms is just 4. And then I have to think about what's left behind when I factor out that 4. So 4 times what gives me 4x squared? Well, 4 times 1 will give me that 4, and then x squared will give me the x squared. I don't need to write 1x squared though, I can just write it as x squared. And then 4 times what gives me 12? Well, that's 3. So this is my standard form, and then this right here is my factored form. Now, because this is an x squared, I would maybe think about factoring further once I do some of my other lessons. Turns out you can't factor this any further, so this is the completely factored form. Another example would be if I had 21n cubed minus 18n squared. So I'm starting in standard form again. You can tell this is not factored form because I'm not multiplying these two together, I'm subtracting them. So I look for the greatest common factor between 21 and 18, and that's going to be 3. So I'm pulling out a 3, and then I look for the greatest common factor between n cubed and n squared. What's the most number of n's that shows up in both? And that's going to be n squared. So I'm taking out a 3, or I'm dividing out a 3 and an n squared from each. And what's left behind here, 3 times 7 gives me 21. And n squared times n will give me n cubed. I'm subtracting, and then 3 times 6 gives me 18, and n squared times 1 will give me n squared, so I can just finish there, and that's factored form. So on your own real quick, try these. 5z squared plus 30, and 8y squared minus 24y. This is really something that we did in 7th grade. You've practiced factoring before using the greatest common factor. You just didn't really know why you were doing it. So hopefully now you're starting to figure out why we would want to do this. So try these on your own, and then hit play again and make sure you got them right. Okay, so 5z squared and 30, the greatest common factor with the numbers is a 5. 5 goes into 5 and 5 goes into 30. This guy doesn't have a variable, so there isn't a variable in the greatest common factor. What's left behind is a z squared plus a 6. Over here, the greatest common factor between 8 and 24 is 8. The greatest common factor between y squared and y is y. So 8y is my greatest common factor for these two terms. If I take out an 8y from 8y squared, I'm left with a y. If I multiplied that out, it would give me 8 times y, or 8y squared. And I'm left with a 3 and then no variable on that guy. So those would be the answers to the two on your own. All right, so now you know one way to factor, which means we're starting to learn how to solve polynomials. We're going to do this using the zero product property. So let's start with something like this. If I had 2w squared equals negative 18w, you have learned ways to solve this. One of the ways you learn to solve this would be to maybe divide each side by w. And this is not the correct way. I just want to let you know. If I divided each side by w, I'd have 2w equals negative 18, divide each side by 2, and I would get w equals negative 9. So that's awesome, and that is true. W does equal negative 9. But that's actually not our only answer. When you have a squared term, or anything greater than a squared term, like cubed or to the fourth power, your basic linear equation solving doesn't quite work as well, because we might have other possible answers. So instead, we need to factor this and use the zero product property. Remember, the zero product property said if we have two things multiplied by each other and they equal 0, that tells you that either A has to be 0 or B has to be 0. So let's start again with this. 2w squared equals negative 18w. What we want to do is we want to get all of the variable terms on the left-hand side. So I'm going to add 18w here. I'm going to add 18w here. So I have 2w squared plus 18w. And then on this side, I had negative 18w. I added 18w. Together, those make 0. So the right-hand side equals 0. And that's what I'm trying to do. I want 0 on one side, because then I can use this zero product property up here. So if these two things together equal 0, then I'll be able to solve this. But you'll notice I'm adding them, not multiplying them, so I can't use this zero product property. Instead, I need to factor this first. So remember what I said earlier, you always try to factor using the greatest common factor first, and if that doesn't work, then you can use the methods that we're going to learn in the next few lessons. But today, funny enough, it's actually going to work using the greatest common factor. So greatest common factor between 2 and 18 is 2. Greatest common factor between w squared and w is just w. If I pull out or divide out a 2w from 2w squared, there's 1w left behind. If I pull out a 2 from 18, there's a 9 left behind, and w from w, there's a 1 left behind, and we don't need to worry about that. So when I factor this using the greatest common factor, here's my standard form. I get 2w times w plus 9 equals 0. Now I can use that zero product property that we learned yesterday. Either 2w equals 0 or w plus 9 equals 0. If 2w equals 0, I would divide each side by 2, and I get w equals 0 divided by 2 is 0. It is not undefined. I'm allowed to divide 0. So w equals 0. Or if I subtract 9 from each side, I get w equals negative 9. So those are my roots of the equation, or my solutions. Notice when we did it this way, I got w equals negative 9. Well, that's one of my answers, but I didn't get this w equals 0, so I only got half of the answer. That's why we're not going to use this method. This is bad. Don't just try to solve it like you solved in 7th grade. You have to factor and use the zero product property to get both possible answers. Okay, so finally we have a word problem. A child jumps straight into the air on a trampoline. The child's height y in feet above the trampoline after t seconds can be modeled by y equals negative 16t squared plus 18t. How many seconds is the child in the air? So this y represents how high the child is after t seconds have passed, and t represents our time. So this does say that the kid's jumping straight into the air. But if you think about what happens as time passes, so this is like when time equals 0 and time is moving on. If y is their height, as time goes on, the kid's getting higher and higher and higher. It hits the peak, and then the kid comes back down and lands back on the trampoline. So even though the kid's jumping straight up and down, if you think in your head about what's going on, over time, it's going to make this arc. So when time equals 0 is when the kid is going to start the jump, but we need to know how much time has passed, so when the kid lands back down. And you'll notice that the kid is on the trampoline when y equals 0. So when their height is 0, that's when the kid has not, is back down on the trampoline. So when they start, their height is 0. When they land, their height is 0. Remember, it's the height above the trampoline. So what that tells me is I'm going to use this equation where y equals 0. So whenever you're doing one of these where you're trying to find out like what the height is, or how high the ball goes up in the air, that comes up a lot, or how much time has passed, you're usually going to set it equal to 0. Set your original equation equal to 0. So now that this is set equal to 0, I can see that this is not in factored form, so I need to factor it. The greatest common factor between 16 and 18 is 2, so I'm going to pull a 2 out. Greatest common factor between t squared and t is a t. And then I need to see what's left behind. 2 times negative 8 gives me negative 16, and I need another t there. T times t is t squared. 2 times 9 gives me 18, and I don't need a t. So these are my two equations, these are my two factors, t squared and negative 8t plus 9. If this equals 0, that tells me that either 2t equals 0 or negative 8t plus 9 equals 0. Over here, I would divide each side by 2. 0 divided by 2 is 0. So the kid is on the trampoline when time equals 0. Well, we knew that already. That just makes sense. For this one, I'm going to subtract 9 from each side. I get negative 9 equals negative 8t. Divide each side by negative 8. Here I have a negative times a negative, which is going to give me a positive. That's important. I can't have negative time. Stuff isn't happening in reverse. So I get that time equals 9/8, or that's actually going to be, if I use a calculator or my head, I get 1.125 seconds. So the kid leaves the trampoline when time equals 0, hits the trampoline when my time is 1.125 seconds. So that means the kid is in the air for 1.125 seconds. That's how much time has passed. So hopefully that made sense. There's another example in your book, example 3, that covers a very similar thing. And of course, if you need any help, you can always ask your teacher. Your homework for today. Oops, that's at the bottom of the page. Your homework is going to be on page 366. Or starts on page 366. You're going to do 1, 2, 6 through 32 even, 23, 31, and 33 through 36. So again, that kind of looks like a lot, but hopefully you can see that these are pretty quick problems and it shouldn't take you too long. So good luck.